Hello viewers, in today's session we are going to discuss another important application of Lagrange's mean value theorem related to inequalities, right? So here we have to prove this inequality in which we are given q minus p divided by 2 times square root of p is greater than square root of q minus square root of p if P and Q are both greater than 0 and Q is greater than P, right? So we have to establish this inequality if this condition holds, and will prove this inequality with the help of Lagrange mean value theorem, right? So before proving this inequality, let us quickly see the statement of the famous Lagrange's mean value theorem. So the statement of Lagrange's mean value theorem, it goes like this. If we have a function, say y is equal to f of x, and it is defined in some interval, say a comma b, right? And if this function, it satisfies two important conditions, that is the function f is continuous and differentiable, but here the function must be continuous in the closed interval a comma b, and differentiable or derivable in the open interval a comma b, right? So once this function satisfies these two important conditions of continuity and differentiability in the required intervals, then Lagrange's mean value theorem says that there must exist at least one point, say C, lying between A and B, such that the derivative of this function f of x at this point, that is f prime of C, must be equal to f of b minus f of a divided by b minus a, right? So here this is the quick revision of Lagrange's mean value theorem, right? So now let us apply this theorem to an appropriate function in a given interval, right? So here we'll first frame an appropriate function, and will also give or provide an important interval in which the function is defined. So let us assume a function that is f of t is equal to square root of t, right? So here we are using the variable t, right? Okay, now we'll define this function f of t in the interval that is p comma q, right? Where p is greater than 0, that is p and q both are greater than 0 and q is greater than p, right? Now this function f of t is the square root function, so this function is obviously defined for all values of p and q, because here p and q are positive numbers, right? So this function, square root function, is continuous in the closed interval p comma q. So here we observe that this function f of t is continuous in the interval that is p comma q, right? And if we differentiate this function with respect to t, we'll get f prime of t, that is the derivative of square root of t, which is 1 over 2 times square root of t, right? Now since p and q both are greater than 0 and positive, so the derivative, it exists for all values of p and q lying in the interval, in the open interval, that is p comma q, right? So this function f of t is continuous in the closed interval p comma q, and the function is differentiable or derivable in the open interval p comma q, right? Now Lagrange's mean value theorem says that there must exist a point C which lies between P and Q, right? So here we have C which lies between P and Q, and these three numbers are obviously greater than 0, right? So f prime of C must be equal to f of B is Q. So here we have f of Q minus f of P divided by Q minus P. Now f prime of C can be written by replacing this T by C. So we have 1 over 2 times square root of C is equal to f of Q. F of Q can be obtained by replacing T by Q. So here we have square root of Q, then we have square root of P. F of P can be obtained by replacing T by P, and here we have Q minus P. So now we have this important equation due to Lagrange's mean value theorem. So now to move further, we'll make use of this inequality, right? Now here this C, it lies between P and Q. So now what we will do, we'll take the square root of all these three numbers. So here we have square root of P, here we have square root of C, and here we have square root of Q, right? Now taking the reciprocal throughout, that is taking the reciprocal of all these three numbers. So we have 1 over square root of P, here we have 1 over square root of C, and here we have 1 over square root of Q, right? And when we take the reciprocal, the direction of the inequality, it get reversed. So now multiplying this inequality throughout by half, right? Because here we have 1 over 2 times square root of C. So now we have 1 over 2 times square root of P, and here we have 1 over 2 times square root of C, and here we have 2 times square root of Q, right? So now rewriting this inequality as 1 over 2 times square root of Q is less than 1 over 2 times square root of C. Here we have 1 over 2 times square root of P, right? Okay, so now here we have obtained this term, that is 1 over 2 times square root of C. So replacing this term by this expression, what we will get, we have 1 over 2 times square root of Q, and then we have here square root of Q minus square root of P, and then we have here Q minus P, and this is 1 over 2 times square root of P, right? So now from this inequality, what we will do, we'll retain only these two terms, right? That is, we'll retain only this part of the inequality to arrive at this result. So we'll neglect this term, that is 1 over 2 times square root of Q, because here we require only this one. So we have square root of Q minus square root of P over Q minus P is less than 1 over 2 times square root of P, right? And we can also frame another inequality, that is by taking this part. So we can also write here 1 over 2 times square root of Q is less than square root of Q minus square root of P over Q minus P. So from this inequality, we can frame two further inequalities, or two separate inequalities, right? But we have to take only this one, because this inequality will lead us to this result, right? So now multiplying both sides of this inequality by Q minus P, right? And here remember, Q minus P is a positive quantity, because here we have 0 less than p, and this is less than q. So p is less than q, so q minus p is greater than 0, right? So q minus p is a positive quantity, and there is no harm in multiplying this inequality both sides by this expression q minus p, right? So here see, this term get cancelled, so we are left with only this one, that is square root of q minus square root of p, and here we'll multiply this one by q minus p, right? So here we have q minus p divided by 2 times square root of p, right? So where this is our required inequality. We can also rearrange the inequality by writing this term to the left hand side and this term to the right hand side, so that we have q minus p over 2 times square root of p is greater than uh, square root of q minus square root of pi, right? So now the form is the form of both the inequalities is same, right? So viewers, here we have seen that when we have taken this part of this inequality, we got this inequality, and when we take this part, which is written over here, then if we multiply both sides of this inequality by this factor, that is q minus p, then we'll also get another inequality, right? So here we have q minus p times 1 is q minus p, and here we have 2 times square root of q, and here this term get cancelled with this one, so we have simply square root of q minus square root of p, right? So this is another inequality, right? So this is how by making use of the concept of Lagrange's mean value theorem, we can establish these kind of inequalities.